Who has tried hyperbaric oxygen in their recent past? Who has not yet tried a chamber yet? There are some chambers in the vendor hall. I encourage you to give it a spin while you're here this weekend. It will not disappoint, I promise. So we're going to be talking about hyperbaric oxygen. I really want to give people a baseline understanding about how this device actually works, what it actually is being used for, both on-label and off-label, and why you might want to consider utilizing it somewhere in your life, depending on either what your health goals are or maybe what your health concerns might be. It's very likely that oxygen could play a critical role in really improving your health. I am on the board and the faculty for the International Hyperbaric Association. I'm also on the board and the faculty for the International Board of Undersea Medicine, where we train doctors, train clinicians, train technicians in hyperbaric medicine, really just trying to get this device out there in the world. It's growing in awareness, it's growing in popularity as we speak, but it really it hasn't hit the point yet that it's on every corner. And part of my job, I believe, is to really excite people about hyperbaric oxygen, really educate them on why it should be a part of their process, because it is an incredible device, it's an incredible modality, and it's very unique in what it's able to actually do for people. Currently, I'm just about to finish a PhD in molecular biology focused in regenerative medicine, and all of my research is actually on hyperbaric oxygen, comparing different pressures, lower pressure hyperbarics to higher pressure hyperbarics, and what effect that has on cellular regeneration, on inflammation, on epigenetics, on DNA repair, all of that information. So we're going to do a quick introduction, a little HBOT 101, just so I get everyone on the same page. And then we're going to talk about the mechanisms of action, because we're really utilizing this device off-label primarily. And when we're using it off-label, we need to have a really good understanding of why are we choosing to utilize this therapy. Does it make sense to apply this therapy for this person's condition or for this person's health goals? And then hopefully we'll have time to go over some myths and even some of the current research out there. So, what is hyperbaric oxygen? Literally, hyperbaric oxygen is breathing air or enriched oxygen at any pressure greater than whatever pressure you are acclimated to. Here we're at sea level, so any pressure greater than 1 atmosphere would be considered hyperbarics. If you're starting in Denver, where you're already a mile high, and you're adapted to that altitude, hyperbarics would be any pressure greater than that atmospheric pressure. But atmospheric pressure does play a big role in this process. It does work air only, so most people do add oxygen when they're doing this therapy, but it is not a requirement. You can breathe air only and still get a tremendous amount of benefits from hyperbaric therapy. What are some of the benefits? This is a short list of benefits. Things like increased ATP production or energy, a balancing of the oxidative or the redox reactions inside of our body, new blood vessel growth, stem cell mobilization, reduced inflammation, growth factor release, mitochondrial performance. It also helps to kill anaerobic bacteria. There are a lot of benefits of hyperbaric oxygen. So the question becomes, why is it so underutilized? So it's a safe therapy, it's an effective therapy. The research is growing literally month after month. Yet it still is probably one of the most powerful tools in all of the biohacking industry, quite honestly. We use all the tools in the clinics that we run. We have red light, we use IVs, methylene blue. We have a lot of different toys and tools at our office, PEMF. But I will tell you, and I promise this to be true, hyperbaric is one of, if not the most powerful tool in that toolbox. And yet, not everybody is doing it. It's not available as readily as I believe that it should be. So why is that? I think it's because there's still a lot of myths in the industry. I think these myths lead to a lot of misunderstandings. And as clinicians wanting to maybe offer new therapies to their client base, because of the myths and misconceptions, it ends up being an underutilized therapy that hopefully we're changing as time goes on. So what is hyperbaric? Why is it so unique? Why is it able to do something that literally nothing else out there can do? That's what we're going to talk about. So essentially we said that this is just pressurized air or pressurized oxygen. Oxygen absorption inside your body, even right now, it follows the law of diffusion. In other words, it doesn't take any energy to extract oxygen out of the air. The pressure of oxygen in the air that you're breathing has to be higher than the pressure of oxygen in your lungs. The pressure of oxygen in your lungs has to be greater than the pressure of oxygen in circulation. The pressure of oxygen in circulation has to be higher than the pressure of oxygen in your cell. And as long as there's a pressure gradient, you're going to be driving oxygen from the air you're breathing all the way down into the mitochondria without using any energy to do it. And we need that oxygen in the mitochondria in order to produce cellular energy. So the law of diffusion just states that molecules move from high concentration to low concentration. The power of that movement, sorry, I skipped one there. The power or the rate of that movement is relative to the pressure gradient difference. In other words, if I have 99 molecules over here and 1 molecule over here on this side, there's a lot of drive wanting these 99 molecules to move down their concentration gradient. If I only have 51 molecules on this side and 49 on this side, they're almost in equilibrium. There's not a lot of drive to move that oxygen down the concentration gradient. And then molecules will always continue to move down their concentration gradient until they reach a point of saturation or equilibrium. But inside your body, you will never reach saturation or equilibrium, because as quickly as you can drive additional oxygen into your body, your cells will metabolize that oxygen, your mitochondria will utilize that oxygen for ATP production. You would actually become oxygen toxic before you became oxygen saturated. In order to really understand what hyperbaric is doing, I think this is an important journey to go on. You've all had an experience where you've gone up in elevation. Maybe you went to Denver on vacation or to Utah. Maybe you took a hike up a mountain and you noticed it was harder to breathe. It's not harder to breathe at elevation because there's less oxygen, exactly. It's because there's less pressure. So as you go up in elevation and you lose atmospheric pressure, molecules of oxygen slowly start to separate. So if I take a full volume of air into my lungs here, I might bring in, let's say, 100 units of air. Well, if I was at the top of Mount Everest, I could still take a full volume of air into my lungs, but because there's less concentration, because there's less pressure, there's less driving force of moving that oxygen from my lungs into my circulation. That's why it's harder to breathe. Air is 21% oxygen no matter where you are on planet Earth, but the loss of pressure is what we feel when we're at elevation. So the opposite is then true as you go below sea level. As you go below sea level, pressures are increasing. As pressures increase, you're compressing those oxygen molecules or those air molecules closer and closer together. So that same volume of air that I'm taking into my lungs at an increased pressure or at depth is going to increase the number of oxygen molecules that enter my lungs, which is then going to increase that concentration gradient, driving that oxygen into my circulation. At sea level, which is where we are here, there's just the right amount of pressure, breathing air only, that you would saturate red blood cells virtually almost 100%. There's very little oxygen that is free floating in your blood right now. Almost all of the oxygen that you're carrying in this moment is bound to a red blood cell. If you put a pulse oximeter on your finger, if you've had that experience, when you put a pulse oximeter on your finger, if your heart is healthy and your lungs are healthy and you're breathing air at 1 atmosphere, you should get a healthy reading on a pulse oximeter of about 98 to 100%. Meaning, right now, as you sit here listening to me, you cannot carry much more oxygen than you're already carrying in this moment. Hyperbarics starts to defy those principles. So there's 2 main gas laws that we talk about with hyperbarics. One is Boyle's law, which says, as I increase pressure, I can make a gas take up a smaller space. I can compress that gas to take up a smaller volume. And then Henry's law, which says, as I pressurize that gas and I compress it into a smaller volume, I can now dissolve greater amounts of that gas into a liquid. I think a seltzer bottle might be the easiest way to understand that. In this case, if I didn't show you the labels and I had a bottle of seltzer and a bottle of water and you didn't see the label, you couldn't touch them, you could only see them from a distance, you might not know which one was water and which one was seltzer, though you clearly know that there's a huge difference between the two. How would you know the difference? Well, I could show you the label, or we could open them up and pour them out. And if I open them up and pour them out, now you see the physical characteristical difference between the water and the seltzer. In this case, what did we do? We pressurized a gas, in this case, carbon dioxide. We held it over a liquid, in this case, water, And then we drove an increased level of carbon dioxide into that bottle of water, and then we capped it, keeping that carbon dioxide, those bubbles, in solution so that you can't see the difference. What's happening inside of a hyperbaric chamber? It's the exact same process. We're pressurizing a gas, but in this case, we're pressurizing oxygen. As we pressurize oxygen or air inside of that chamber, we also happen to be holding it over a liquid. However, in this case, the liquid that we're holding it over in your lungs is your blood plasma. And so as we pressurize the oxygen, hold it over your blood plasma, we can now not only saturate your red blood cells, but that's the easy part. We can now supersaturate your plasma. Your plasma typically only holds about 3 milliliters of oxygen per liter of blood. It's a very small amount. Under hyperbaric conditions, we can make that 20 times higher. So there's an incredible reservoir in your plasma of possible oxygen absorption under hyperbaric conditions. And again, most of the oxygen you're carrying is bound to the red blood cells. However, in this hyperbaric environment, they're bound to red blood cells, and now there's oxygen free floating inside your plasma. What are some of the benefits of that? The first one, very simply, is that free-floating oxygen doesn't have to follow all the rules that red blood cell-bound oxygen follows. Therefore, it's literally able to reach every nook and cranny inside your body, every little cell that might be injured or damaged. It doesn't have to follow, because it's not bound to red blood cells, it doesn't have to follow any of those laws. The second is really important. What if you had capillary damage, a capillary blockage, or for whatever reason there's an issue with red blood cells reaching tissues? We know that if oxygen is bound to the red blood cell and there's any blockages, what would happen to any of the cells and tissues on the other side of that blockage? They'd become hypoxic and eventually necrotic and die. However, if you're dissolving oxygen now into the plasma, nothing stops the liquid from moving. And now all of a sudden, in the short term, you're immediately delivering oxygen to hypoxic cells and tissues. And then in the long term, you're actually stimulating angiogenesis, which is going to help heal the endothelial lining of your blood vessels and capillaries, and in fact grow new capillary beds for improved oxygenation. Once you even pull the therapy, now those cells and tissues can oxygenate themselves. And then the third really important benefit of hyperbaric is back to that seltzer analogy. When you pressurized that bottle of seltzer, you drove oxygen in, and when you took the cap off, what happened? All of that carbon dioxide started coming out. Well, when you go into the chamber, you're driving all of this oxygen into your circulation. And we used to think that that was the entire process of hyperbaric. It's all about how much can I drive into this person. Well, I'm telling you now that that's less than half of the benefit. Probably close to 80% of the benefit is not the amount of oxygen you're driving in. It's that when you get out of the chamber, all of that oxygen is now trying to get out. And as all that oxygen is trying to get out, it can't leave your body, but now it's able to interact with so many more cells and tissues because it's under pressure. The distance that oxygen can travel away from a capillary is almost 4 times greater after hyperbaric than before hyperbaric. So when you have, let's say, a stroke case, where there is an ischemic issue and cells are either dormant or damaged or even potentially dead. And now you have broken capillaries in that area. Because you're getting out of the chamber and oxygen could travel so far, you can now nourish a lot of that surrounding tissue, those dormant cells, and really wake them up and start the healing process. Just to put some numbers to this concept, right now in your capillary, the pressure of oxygen is about 50 millimeters of mercury. If instead of going into a chamber, I gave you a mask of oxygen and you were just breathing 100% oxygen at the surface, you can raise capillary PO2 a little bit, the pressure of oxygen. So you can get it to go from about 50 millimeters of mercury to about 75. That's not nothing, that is certainly something. However, let's just go to a mild pressure. Let's say you went to 1.3 atmospheres on 100% oxygen. Instead of 50 millimeters of mercury, you can now get to 250 millimeters of mercury. You're raising PO2 almost 5 times. And again, remember, the entire process of oxygen absorption in the cell is driven by gradient. The larger the gradient that we can create, the more oxygen we can drive in. So even in a mild chamber with enriched oxygen, we're looking at a 5 times increase in oxygenation to the mitochondria. If you went a little deeper yet and went to 1.5 atmospheres on 100% oxygen, you're now at 437. And it only gets more exponential the deeper you go. So let's talk a little bit about mechanisms of action. I use this slide very often when I'm lecturing to really drive home the important role that hyperbaric is playing in chronic illness, but also in longevity and aging. You can pick anywhere you want to start on this cycle. We're gonna start at the top just for ease of conversation. But for some reason, there's hypoperfusion. In other words, maybe there's toxicity, maybe there's capillary damage, maybe there's inflammation, some sort of blockage of oxygen getting into the cell. So you have hypoperfusion, leading to a reduction in blood flow. As you have reduced blood flow, you can no longer nourish the cells with oxygen and nutrients, and you can no longer remove the waste products the way the cells need to. So now you have cells that are basically bathing in their own waste, so inflammation starts to rise, and you start to get metabolic dysfunction because you can't nourish the oxygen with the fuel, nourish those cells with the fuel and the oxygen that those cells need to even just to perform normal functions. As inflammation starts to rise, you get increase in reactive oxygen species, you start to get cell signaling disruption, which leads to cell damage, epigenetic damage, DNA damage, cell membrane damage, nuclear membrane damage, and then eventually tissue damage, and then further hypoperfusion, and the cycle continues. What you would see if you compared the pillars of chronic illness to what we all know as the hallmarks of aging, there's a lot of crossover here. There's attrition of your telomeres, there's a reduction in stem cell mobilization, cellular senescence, altered intracellular communication, mitochondrial dysfunction. These are all very similar components to the pillars of chronic illness. We all also know that aging is your #1 risk factor for all chronic illnesses. Here are the well-known, non-controversial, well-studied mechanisms of action of hyperbaric. You may understand what most of them mean, you may not. I'll quickly go over them. Hyperoxygenation literally just means driving more oxygen. Reduced oxidation. Wait a minute, isn't hyperbaric an oxygen therapy? Doesn't that cause oxidative stress? Somehow, it actually doesn't increase levels of oxidation. Long-term, it reduces oxidation. Vasoconstriction, which actually helps to control swelling and edema. Reduce cytokines or reducing inflammation. Toxin inhibition, by reducing toxins that microorganisms, like certain infections, might release inside your body, but also upregulating and improving your own detox mechanisms. White blood cell oxidative response. Your white blood cells, when they're fighting infection, use reactive oxygen species as part of that fight. Hyperbaric increases our immune system's ability to fight infection. Collagen synthesis. Hyperbaric stimulates growth factors that are geared towards soft tissue repair, muscle, tendon, ligament, cartilage, bone, skin. All of your connective tissues are stimulated through hyperbaric oxygen. Antibiotic synergy in cases where antibiotics are necessary, especially with, let's say, antibiotic-resistant pathogens. Hyperbaric actually helps to break down biofilms that are a hallmark of a lot of these anaerobic infections. Angiogenesis, we spoke about, the building of new blood vessels. Neurogenesis, literally rebuilding and healing the nervous system, improving synapse connections, stimulating neuroplasticity. Mitogenesis, increasing the size and the shape of your mitochondria, even increasing the number of mitochondria. Fibroblast proliferation is back to your soft tissue healing, stem cell mobilization, and then increase in reverse transcriptase. That's actually, if you looked at if any of you have seen the study on hyperbaric and telomeres, reverse transcriptase is a polymerase that basically helps to rebuild telomere length. And so hyperbaric has been well known to do that as well. So I started this little section with a very similar slide, but it was the opposite. Because what I want to show you is I almost never use hyperbaric alone in my office. We use hyperbaric and a lot of other therapies depending on what this person might need. But if all you did was use hyperbaric oxygen, we'll start again at the top. Where you had hypoperfusion, you now have hyperperfusion. Where you had reduced blood flow, you're improving blood flow and you're building new capillaries. Where you had increased inflammation and metabolic dysfunction, you're actually reducing the inflammatory response and improving cellular metabolism. Where you had immune system imbalance and inflammation rising, you get a reduction in inflammation, you get a balancing of the reactive oxygen species, you get a normalization of cell signaling, which improves also cellular senescence, by the way. You start to get cellular repair, cell membrane repair, mitochondrial repair, neuron repair, DNA repair, epigenetic repair, and eventually you'll start to get cell and tissue repair to follow. So even if all you did was use hyperbaric by itself, you're literally touching every single one of the pillars of chronic illness just with that one modality. Imagine if you started to utilize all the other tools and strategies that you well know that you probably already use. The synergy here is incredible. I like to break some of the benefits down into short-term benefits and long-term benefits just to give people an idea of what to expect. Short-term benefits, you can assume, are going to happen in about 10 hours of treatment or less. So right away, you start to get increased amounts of ATP production. You get reduced swelling and edema if that's something somebody's dealing with. You get a reduction in inflammation. You improve oxygen perfusion into the cells and tissues. You start the process of immune regulation, and you start to increase your body's antioxidant system. Long-term benefits, I would say that this is at least 20 hours or more. In many cases, it's closer to 30 or 40 hours to really get some of these systems upregulated. Here you're getting new blood vessel growth. You're getting increased size of mitochondria, and you're literally replicating your mitochondria. You're going to have more mitochondria inside your cells as a result of prolonged hyperbaric exposures. You start to get neuroplasticity. It starts to kill infections, particularly anaerobic pathogens. We start to reduce cellular senescence. We improve epigenetic expression, particularly on gene silencing, which is critical in longevity, as you probably well know. And you get upregulation of stem cells, both mesenchymal stem cells as well as central nervous system stem cells. So let's go over some of the myths here. Before I do, let me just say out loud, I have probably over 600 videos on YouTube, some of which address a lot of the hyperbaric myths, and then 580 other videos that talk about hyperbaric as a whole. So if you're interested in learning more about hyperbaric, because I'm going to run out of time while I'm talking, you could scan that QR code, take a look at our channel. Also, the research that I just finished, I'm finally talking about. So I'm defending it in about 3 weeks. I graduate in May. Yay. And over the next few weeks, I'm releasing different sections of the research. Again, it's 1.3 atmospheres versus 2.0 atmospheres, and what we found throughout that process of about 50 hours worth of treatment. So over the next 3 or 4 weeks, we're releasing one video a week talking about that research. So if you're on that channel, you'll start to see a lot of that data coming out. But I do want to address some of the myths, because this is a confusing component for a lot of people with hyperbaric. The first is oxidative stress. Hyperbaric is oxidative. You're using oxygen. When you upregulate mitochondrial function, you also release more free radicals. 100% you do. Please don't think that I'm unaware of the fact that that's true. It is. However, any research that's looked at long-term hyperbaric exposures doesn't show increased oxidative stress. And it's actually the opposite. It shows increased glutathione. It shows increased superoxide dismutase. It shows increased catalase. All of the enzymes that your body utilizes to actually get rid of free radicals, all your endogenous antioxidant systems is basically what that's called, upregulate as a result of hyperbaric. So hyperbaric does not deplete you of your antioxidants. It actually stimulates your body's antioxidant system to work harder. And not only will that improve your resilience to an oxidative treatment like hyperbaric, but it also seems to improve people's response to the oxidation in the outside world that we actually have less control over. How about oxygen toxicity? If you use hyperbaric, somebody along the way has said to you, don't you know how dangerous oxygen is? Don't you know that oxygen is toxic? How could you use such a thing? It's so dangerous. So I'm not telling you that oxygen toxicity is not a thing. It most absolutely is. However, it's also very easy to avoid oxygen toxicity. There's two different types: pulmonary oxygen toxicity and central nervous system oxygen toxicity. I have many videos on YouTube going into detail, which I can't go into here, but what I could tell you is, Unless you're going to 2 atmospheres or more, you're never going to reach levels of central nervous system oxygen toxicity. It's almost impossible. Once you go to 2 atmospheres or above, now it's a conversation. However, taking air breaks every 20 minutes from the oxygen alleviates almost all of the risk of oxygen toxicity. So as long as you understand that oxygen can be toxic at high levels and you put together systems and protocols to avoid oxygen toxicity, it's really not that difficult. There's also pulmonary oxygen toxicity, which almost has nothing to do with hyperbarics other than it's a cumulative effect of oxygen exposures over time. But as long as you're getting breaks from oxygen, the oxygen clock starts every 24 hours. So if all you're doing is a 60-minute session or a 90-minute session, even if you were doing 2 or 3 hour sessions, which are rare, and I don't recommend necessarily for most people, you're never going to reach levels of pulmonary oxygen toxicity. Another comment or question I get all the time is, why do I need hyperbaric? Can't I just get oxygen and just breathe it at the surface? Well, that's what we were talking about in terms of elevation changes. You could do that. There is some benefit to that. But if you remember those numbers I showed you, your capillary pressure right now is about 50 millimeters of mercury. If you're breathing 100% oxygen, you can get it from about 50 to 75. But that's not even touching mild hyperbarics with enriched oxygen, which was 5 times the amount of oxygen. If you go to 2 atmospheres on 100% oxygen, you're getting almost 14 times the amount of oxygen that you and I are getting right now. If you go to 2.6 atmospheres on 100% oxygen, you're getting almost 20 times the amount of oxygen that you and I are getting right now. So you could never get anywhere near that using something like oxygen at the surface. What about HBOT? That's another one I get. There is another video. You should watch that video if you have that question. I love HBOT. I think it's an exercise with oxygen therapy is what that stands for. I think it's an incredible tool. Please don't think that I don't. I love all oxygen tools, okay? I'm partial to hyperbaric for certain reasons, but it's not like I would say that ozone is bad and hyperbaric is good. That's not going to come out of my mouth. I love all of these treatments, but it's completely different, and they shouldn't even be compared to one another. HBOT is exercising with oxygen. So you can change the intensities of your exercise levels, and you can change the amount of oxygen, either hyperoxygenated or even mildly hypoxic, while you're changing the intensities of your exercise. If you're training for something, that's an incredible tool. If you're training for altitude-related exercise, it's an incredible tool. If you want to train your red blood cells to be more effective and more flexible from an oxygen absorption and oxygen delivery standpoint, that's an incredible tool. You are never going to create the amount of oxygen in your system using something like HBOT as compared to hyperbaric. So if you're using it as a training tool or a red blood cell healing modality, it's a great tool. If you're using it for driving oxygen into your system for cellular repair, tissue repair, or regeneration, it's never going to have that impact. Also, your body is constantly shunting oxygen from one area of your body to another area based on use, correct? So if there, God forbid, there was a fire in here, we'd all jump up and run out of here. Your body would shunt blood to your legs so that you have the oxygen to working tissues. I say that because if somebody has a TBI and you're trying to drive oxygen to their brain and you're using HBOT, which is, let's just say, in this case, on a bicycle, what tissue is working the hardest? Your legs. So even though you are absolutely driving more oxygen into your body, you're playing with the supply and demand mechanisms, which is incredible. Most of that oxygen is going to the working tissue, your legs. It's not going up to your head for TBI repair and recovery. Versus, let's say, hyperbaric, where you're just basically laying passive, driving oxygen into the system, allowing the body to utilize that oxygen however the body sees fit. I'll finish with ozone. Again, I love ozone. We use ozone in our office regularly. Ozone is a much higher degree of a free radical than O2, right? Ozone is O3. It's a more reactive oxygen molecule. Hyperbarics, we're using molecular oxygen, which is O2. When you use O2, you breathe it in, it drives to your mitochondria produce energy, and you might release some free radicals. Ozone, you are putting a free radical into the body. If you're trying to fight infection, as one example, ozone would be more powerful than hyperbaric. Hyperbaric helps fight infection, ozone does it better. If your goal is tissue repair and tissue regeneration, epigenetic expression, mitochondrial function, telomere lengthening, or any of these other types, hyperbaric will be far more effective than ozone could ever be. So it's not that one is good and one is bad in any of these cases. It's really that, what is the goal? What are the health concerns the person is coming in with? What are the health goals that the person is coming in with, or that you have in yourself for your personal health and your personal fitness? And how do we apply the right tool to the right person at the right place at the right time? I probably have 4 hours more information that I can share with you, but I only have 30 seconds, and I'm making an effort to stay on time. So I appreciate your time and attention. Take a look at those videos, and I'll be here walking around if you have any questions. Thank you so much.
Jason Saunders, ladies and gentlemen.